Hi, I'm Jillian Magyar, and I will be presenting this project on non-emergency response time prediction using deep learning, and I'm from SUNY Brockport. So the problem statement for this project is resource allocation for management of non-emergency incidents is an important problem that needs to be addressed for smooth functioning of cities. In this research, we investigate how long it takes to resolve non-emergency requests in cities, which enables efficient resource planning for future incidents. Some examples of non-emergency incidents are noise complaints, illegal parking, or sidewalk damage, or anything like that. The data was collected and referred to by the publicly available 311 service requests provided by the New York City Open. There are thousands of rows in this data, so we had to sort through it to get the most recent years. We specifically looked at the Department of Environmental Health, the Department of Transportation, and the Department of Sanitation in New York. Column-wise, we only looked at the created date, closed date, and the agency name of the file. For pre-processing, we sorted through the files and only got created and closed dates that were from the recent years. If there was any incident where there was a created date but no closed date in the file, it was also sorted out of the mix. We computed the response time by subtracting the closed date and the created date, and we used Python to look through and sort the file into a more digestible file. Our model is an encoder-decoder sequence-to-sequence long short-term memory based on a recurrent neural network. The hyperparameters we used include one stacked layer, 15 to 35 hidden layers, and the learning rate of 0.01 to 0.001. These hyperparameters gave us the best estimates for our LSTM model to closely and accurately predict the response time of the department signaled. For training our model, we split it into two parts. 75% would be for training and 25% would be for testing. We used the past 2 weeks to predict 1 week in the future. We utilized supervised machine learning, meaning we gave our model the data and results to help it learn the patterns in the data and results so it can accurately predict the future patterns. We used the sliding window approach, which is a problem-solving technique, and the metrics we are using is the root mean square error and the mean absolute error. These are our quantitative results. As you can see, our LSTM model's averages of RMSE and MAE are significantly lower than the linear regression counterpart. Now for our qualitative results. This graph shows the actual response times and the predicted response times for LSTM and the linear regression. The actual response times are in blue, the LSTM predictions are shown in green, and the linear regression predictions are shown in yellow. You will see from the graph the linear regression predicted values in the next time step based on what it sees in the previous time step, whereas the LSTM accurately captures the underlying patterns in the data and gives more accurate predictions. In conclusion, we see that our model accurately predicted the response time for the future. This is an ongoing project, and we are presenting the results obtained so far, and we want to work with other models, like support vector machine or autoregressive integrated moving average, or etc. In this work, we only worked with New York City data, and in the future, we plan to work with other big cities.